corny line. So we're back with another example. These guys don't have the same denominator. I can get them to be the same denominator just by observing the way they factor. How does this first guy factor? X plus 3 times x plus 5. What about the other denominator? X plus
3 and x minus 4.
3 and x minus 4. Now I've got to figure out what's missing. What's missing here?
X minus 4.
I'm missing a factor of x minus 4. I'm going to put that in the numerator as well. What's missing here? X plus 5. Please note that you may not combine fractions unless they have the same denominators, right? So we have to get them to be the same denominators. And we do that by putting in those missing factors. So now I have one common denominator. That's x plus 3, x plus 5, and x minus 4. Now your numerator. What do I get in my first numerator when I multiply that? I get 2x minus 8. What about my other numerator? So it's going to be plus 7x plus 35. Do y'all agree? Well, I can combine those like terms. That's no problem. What do you get when you combine them?
9x plus 27.
Get 9x plus 27 all over these three factors. Is there anything else I can do here? What is that? 9x plus 27 has a common factor of 9, and I'm left with x plus 3. Is that useful to me?
Yes.
It is very useful. Why is that funny?
It's not funny.
Math can be funny. So then, what's the common factor that reduces? X plus 3, and I'm left with just 9 in the numerator over the factors x plus 5 times x minus 4. Now, some of you could get the same answer by lucking into it, but what you did is wrong, and if you were to keep doing that on all of the other problems, you would continue to be wrong and you would never be right.
I got it right. Ha.
So what do you guys think about that? Any questions? Do we ever cancel factors side to side?
No.
Never. If you're going to reduce factors, it has to be one at the top and one at the bottom. Otherwise, what you're doing is, guess what?
Wrong.
Wrong. Can you add fractions before they have the same denominator? No, you get them to be the same denominator so that you can add the numerators or subtract them. Depends on the indicated operation. Do y'all agree?
Agreed.
All right. Let's do one in green. I feel like green has been left out today.
Are you still recording?
Let's try this guy right here.
I was wondering. So I could be quiet.
Now, before we really jump into this problem, there's one thing I want you to understand. This is subtraction, right?
Yes.
And since this is subtraction, you need to make sure that that subtraction symbol doesn't get lost. So what I'm going to do first is turn this into a plus. I'm going to move the negative up here so we know that's really negative 8. I'm afraid that if you don't do that, it may get lost with everything else that we're going to do here. Now, how do I factor these denominators? Because obviously, they're not the same. How do I factor this guy?
The sign in the middle doesn't change the size of the
denominator.
You've got one negative. You can either use the negative in the top or the bottom, not both.
When you use,
If you use it in both,
It's gonna
then
be
you haven't
one.
changed anything. Because if you
Okay.
multiply top and bottom times the negative, it's just multiplying times positive 1.
Okay.
I know your numbers will do 5 and 4, right?
Right when I break down the 20, it's 5 and 4.
Would it be a negative 5 and a positive 4?
You have to end up with a positive at the end, which means
Oh.
the positive must be
5 and 5.
attached to the larger number, and the negative is on the 4. Okay. Now I've got the 2x squared minus 11x plus 12. Well, that's a 2x squared. So I expect this guy to break down as 2x and x. What do you know about your signs before I go on? I have to multiply to get a positive, right? Therefore, the signs must be the same, both negative. Now, what's the right combination for multiplying to get the 12?
Can you do 11 times 1?
Could I do what?
11 times 1?
I need to multiply to get 12.
Oh.
So if I look at those factors, I have 1 and 12, 2 and 6, or 3 and 4. 2 and 6 have a common factor of what? 2. Does 2 go into the middle coefficient? So I cannot use that guy. Should I use 3 and 4 or 1 and 12? What do you think? 3 and 4. Now, remembering the logic that I showed you,
Oh.
what cannot go here?
This is one.
The 4 can't go there, because that would give you a common factor that we don't have, so the 4 goes there and the 3 goes here. Does that give you a negative 11x in the middle?
Yeah.
Minus 3x, minus 4x, excuse me, minus 8x, excuse me. So negative 3 and a negative 8 is negative 11. Now you put in those missing factors. What factor is missing for this first guy? He's missing the 2x minus 3, so top and bottom here. What is this guy missing? He's missing the x plus 5, top and bottom. Do you all agree? All right, let's continue to make this work for us. Now both of my fractions have the same product of factors. X plus 5, x minus 4, and 2x minus 3. The order doesn't matter because it's all multiplication. Now, multiply and combine like terms in the numerator. What will you have? I get 10x, and then what?
Minus 15.
10x minus 15. Now distribute the negative 8. See, I put the subtraction up there so I wouldn't forget it. So distribute, and what do you get?
Minus 8x.
Minus 8x,
Minus 45.
minus 40.
Oh, 40.
Now the only thing left to do is combine like terms, and what do I have?
You have 5, 3, 2, and 5.
Negative 50.
I have 2x
2, 3.
Minus 55.
and minus 55. Right?
Mm-hmm.
Can I do anything with the 2x minus 55?
No.
No, it's a linear, so the only thing you could hope to do would be take out a common factor. But 2 doesn't go into 55, does it? So I'm going to leave it just the way it is.
Why is it negative 40? Oh, okay, yeah.
I have a negative 8, so I get the negative 40 right there. Any other questions about this problem?